Welcome to part 9 of our Competency 17 videos. In this video, we will distinguish between a z-interval and a t-interval on the TI-84 while solving related word problems. Okay, before we begin, we need to discuss what will happen or what's the difference between using a z-interval and a t-interval. The big difference is the number of samples in or sample size. We need the sample size to be greater than 30. Okay, so that's if we want to use a z-test. So let's say we have a sample size of 16. So we go over here and then no, we're a small sample size. Well, we need to look to see if it's a normal distribution. So if it isn't a normal distribution and nowhere is stated that it is, then we probably can't use that information and we stop and we go gather more information. Or let's say they say, assume you have normal distribution somewhere in the word problem. Then the answer is yes. So let's say I know the sample uh, standard deviation. I know it from the sample. So if I know the sample, I say yes, then I can use the z interval. But let's say they don't give me the sample. They give me the population. Remember, we're taking samples. All they give me is the population standard deviation. Well, then my answer is no. Well, I use that. Go ahead and use the information given for my deviation, but I'll have to switch to a t interval. So most of the time, you could say that in most cases, we will just go ahead and use our z interval. Every once in a while, if I don't have the information I need, I can use a t interval. So let's try number 1. Okay, scoot this over a little. Number 1, a survey of 60 homeowners in Austin was conducted, which discovered that the average age of their homes was 25 years with a sample deviation of 4 years. What is the 95% confidence level for the age of the homes in Austin? Okay, for those, and we're talking about that particular area. Okay, we'll talk a little more about that. But okay, so what are we looking at? We have a sample size greater than 30. We know immediately that we can use the z interval because of that. And we do have our sample standard deviation. And here's our mean in years. Remember, all of this is about the years of the homes, not the not how old the homeowners are. So make sure you keep that straight. Okay. So we are saying stat, move over. You see there, that's what we're doing. And we need number 7 for our z. Now for this, you can't push enter. See, if I push enter, it does nothing. You have to arrow down. The reason they do that is you have to decide if you're going to use stats, meaning statistics, given information, which is what we're doing, or here, I'll go back up, or using data. We're not using data. So we need to move over, go down. We have a deviation of 4 years, and our mean is 25, and we have 60 homeowners who were questioned, surveyed, and a confidence level of 0.95 enter. And we get 23.988. Well, let's look at what we have. Be careful. Before that, yes, you can scratch out B and D. But when you look at A and C, obviously there's something wrong with A. These don't make sense. You cannot say that 23.99 is greater than 26. This A just doesn't make sense, so it has to be C. Number 2, 90 mathematics professors at various universities were asked how many minutes they required to grade a student's term paper. The responses showed that the mean time was 18.6 minutes with a sample standard deviation of 3.5 minutes. What is the 99% confidence level for the mean number of minutes required by all mathematics professors to grade a student's term paper? Okay, we have some important things. Okay, here is our confidence level. There's our mean. Okay, we can use a z-score because 90 is a large number and we have all the data we need, and it says that we're using a sample standard deviation. Okay, stats, arrow over. We're using number 7 because we're using z. Okay, so we have the sample standard deviation in there. And then what is our mean? Oh, okay. Our mean is 18.6. Standard deviation, our mean. And now we go to how many were we using? We're using 90. I'm sorry, it took me a second. I didn't write it down. Okay, now we are at 99% confidence. Okay, back. Okay. Now, we need to be careful. We can mark this one out. We can mark this one out. Notice, I like everything about B. Just in case, let's go look at C. I don't like that. That makes no sense. So that can't work. It has to be A. Okay. Now, let's look at number 3. Okay. And remember, when above or earlier in the video, we discussed the our flow chart and the requirements for a flow chart. This one is questionable because of wording, but let's give it a try. The noise level for hospitals is a normal distribution for which the standard deviation is accepted as 4.5 decibels. A health card officer is tasked with creating a 90% confidence level for which the noise levels for the noise levels for all hospitals. He uses a sample of 20 hospitals whose mean noise level is 52 decibels. What is the 90% confidence interval for the mean noise level in decibels for all hospitals? Okay, that was a mouthful. All right, I'm going to get out of this and stat, arrow over twice. Okay, what do we use? Do we use our Z or our T? Let's look at the words. These words right here. Accepted. This implies that it's for the sample and that we are using the Z. Okay, even though our N, our sample size, our N is low, it's less than 30, we can accept that sample as a sample size and use our z-score. So let's try that. Okay, I know that's very confusing. Actually, let's just go back up and look at it real quick. What are we saying? We're saying, okay, the answer is no, but we are normal. That's a thumbs up. So we can keep going to yes, and then is it known? Yeah, we're gonna go ahead. We have it. We know it. It's not it's not the population. It's an accepted for the sample size. So we can say Z. Honestly, this is that's a practice question, and I doubt that the test will give you something so ambiguous. That is very ambiguous. Maybe they wanted to challenge us. So we're going to use our Z interval, and we have to arrow down, and we have a mean. Where's our standard deviation? Oh, 4.5. 4.5, enter. Our mean is 52. Then we had a small sample size of 20, but they want a confidence level of 90%. So, and okay. All right, we can get rid of these. That doesn't make sense. So those won't work. Now let's be careful. Same thing. I like D because it makes sense. You can't have 50 being greater than 53. That doesn't make sense. Okay, now let's look at number 4. In a small city in Texas, a survey of 16 schools was conducted to determine the number of teachers in each school. The result showed a mean of 35 teachers with a sample standard deviation of 5. Assuming that the population of the number of teachers in each school is normally distributed, what is the 90% confidence interval for the mean number of teachers in all Texas schools? Okay. All right. So let's back out of that. Okay. Go over. I have to decide which one I'm going to use. Well, I have a 16. I didn't circle that. That's a small number. 35. My standard deviation. It says sample standard deviation. Okay. It's for the sample. It's not for the population. Okay. Well, let's see what we need to do. Let's see. We're going with a small and a sample. I'm saying I think we should use a T interval. And I'll tell you why I think that. Because it says directly, it doesn't say an accepted sample, but it says a standard sample standard deviation. So let's try that. Let's go with 8. Okay. And we have 35. Okay. Now that's asking for a sample. And that's what we have to put in, and that's what it's asking for. That's what a T interval does. It is specifically for the sample standard deviation. Okay, so we're going to put in a 5, enter, and how many people or surveyed, how many schools rather. And they want a 90%. That's already entered. Okay, we have 32.809. Well, I see some, A looks good. Well, this one says 37. This one says 19. That one says 14. It has to be A. Okay. Number 5. The Texas State Police recorded the speed of each of 24 randomly selected passenger cars on a main roadway. The mean speed of the cars was 43 miles per hour with a standard deviation of 5.5 miles per hour. Assuming that the population of the number of cars on the roadway are normally distributed, what is the 98% confidence level for the mean speed of all the cars on the roadway? 24 implies that this could be a T interval. Okay, we have a standard deviation. It does not say sample. Okay, that is a population deviation. Here's our mean of 43. And we have our confidence level. Okay, if we think about our flow chart, okay, we have yes, and it is normally distributed. So that's a normal distribution. So we're not going to stop. We're going to go ahead and keep going. But we will have to use the t-test because we do not have a sample standard deviation. Okay, so stat over, and we'll go to 8, and we go down, and what do we have for our mean? 43, and our sample is, our deviation is 5.5, sample deviation. We're replacing the population deviation, and that's 24. And what do we want? 98.98. Okay. Okay. Do we have, yes, D is the only option that's actually close enough. Okay, number 6, using the information in number 5, what is the 80% confidence interval for the mean speed of all the cars on the roadway? Okay, well, we can back out, start over, go over 8. We have the same information until we get all the way down to the bottom. And we just put 0.8, and we enter, and we have 41. Looks like B will be the only option. C's kind of close, but no, not close enough. Not all the answers are close enough. Okay, let's go to number 7. And we'll go all the way down, scroll up. Okay, number 7. You want to rent an unfurnished one-bedroom apartment in Austin next year. The mean monthly rent for a random sample of 60 apartments advertised on a popular website that lists apartments for rent is $1,000. Let's go ahead and circle our 60. And the rent mean is normally distributed. So these rents are a normal distribution. Okay, so that'll help us. Assume a population standard deviation. Okay, they just flat told us population is $200. Construct a 95% confidence level. Okay, so what are we going to use? Well, we don't need to make any decisions. That 60 has made the decision for us. We are using a Z interval. Stat over 7, arrow down. Okay, we have 200 is our deviation. Okay, and what is our, okay, wait a minute, standard deviation, but our mean is 1,000. Yes, that's correct. Oh, no, it's not. It'd help if I put in all the zeros. Okay, now we have a large enough sample size. We push enter, but they want 95, so 0.95%. And we have $949.39 would be our lower price. So that's not, that's too low. This one's too high. Too low. Our answer has to be C. Number 8. Devin kept careful records of the fuel efficiency of his car. After the first 25 times he filled up the tank, he found the mean was 23.4 miles per gallon with a population standard deviation of zero point 0.9. Assuming the data of fill-ups is normally distributed, compute the 95% confidence interval for his miles per gallon. Okay, those questions, those are such a mouthful, so long. So we have to decide what we're going to do. Are we going to use a T or a Z? Well, that's a small sample size of 25. What makes me agree with a T interval is it says population standard deviation. It is not a sample deviation. So I'm going to say number 8. We'll go down. So our mean is 23.4, arrow down. Now we have to go with the population deviation. Replace. So we're going to replace the 0.9. And always, look over, it says SX. That means sample deviation. This plain X. Remember, X bars are mean. This plain X is replacing the sigma for the standard deviation symbol. And put in our 25, enter, and we have 90.5% in. Okay, 23. Oh, I see B. That looks good. Yep. A's not going to work. C's not going to work. B's not going to work. Definitely B. And that's our last question. I thank you very much for giving me your time and putting up with the little conversations that I have trying to explain things. If you like these videos, could you please subscribe or at least give us a good thumbs up? And thank you again.